All right, this is an example of a loss development triangle. What we have here, we're going to do cumulative paid loss development for the insurance industry itself, the property casualty insurance industry. As explained in the notes, anytime a claim comes up, whether it's reported or not reported, but whenever the incident that caused the claim is in a particular calendar year, that is assigned to that year forevermore. Okay, so if you had a car accident in 2005, and even if you weren't ever sued, even if there weren't any damages, it still is a 2005 accident year loss. It might be you ran over somebody and y'all went to court and it's 10 years later before anybody decides to pay on the claim. It still is a 2005 year claim. All right, so everything's put by the accident year so we can track how it develops over time. These are cumulative paid losses. Okay, so 1998 is our first year here. After 1 year, that means as of the end of 1998, the industry had paid $88,210,000,000 on that. Their estimate was that eventually, when all these are added together, it'll cost about $203 billion. As you go across, you see the numbers going up. That's as a claim is paid, then those claim payments get put into the aggregate for paid claims for accident year 1998. Now, this is all insurance companies reporting to the National Association of Insurance Commissioners, which makes it pretty much all insurance in the U.S. So this is cumulative after 1 year is at the end of 1998, the next year is the end of 1999, the next year is the end of 2000, 2001, 2002, 2003, 2004, 2005, 2006, 2007. Now this data comes from the 2007 financial statement data, so this is before we have 2008, 9, 10, or beyond that. All right, so we go to the next accident year, 1999 is on this row. The cumulative paid after 1 year is the amount paid as of 12/31/1999. 2000, 2001, 2002, 2003, 2004, 2005, 2006, 2007. And again, with the data we're using, it stops at 2007. The 2007 accident year has only 1 year of development. That's the accident year as of 12/31/2007. Okay, so notice that with each of these years, like we're looking here at the cumulative paid losses for 2002 after 1 year, about 230 billion, but so far only about 104 million been paid, and then the numbers start going up. So what we want to look for is a pattern in how the numbers increase. If the numbers increase in a predictable pattern that matches up from year to year, then I can use the pattern from 1998 to forecast the pattern for 2007 and beyond. Okay? So loss development factors. The first thing to do with this particular approach, we're going to take the cumulative after 2 years and divide it by the cumulative after 1 year. And that means that going from the end of this year to the end of this year, the claims payments went up by 48%. So the cumulative is about 1.487 times as much as the amount after the first year. It's about 1.497 for 2007. In fact, I can copy this down, and I'm going to get a zero or an error message here for the latest year, 2007, because as of the date of these statements, they don't have 2008 statement data. Okay? So that's the reason that we're only using 1998 through 2007 is that's the data set I have. All right. So if we do the same calculation and copy it over here again, Again, the last year is going to drop off because 2006, as of 2006, as of 2007, there is no data beyond 2007. But what I can do is fill in the triangle. I'll lose a year of data at each point. Okay, but hopefully what I can do is use this data to do some forecasting about what that number ought to be. Now 1.48, 1.49, 1.5, 1.49, 1.68, 1.459. The easiest thing to do is to take a simple arithmetic mean of this. You add all the numbers and divide by however many numbers there are. And that's 1.482. That's the arithmetic mean. But there's other measures of central tendency. The other thing we want to look at is, are these numbers changing over time? And what we see is, wow, they should be more random than this, and they're not. Now, that's the bad news. Here's the good news. We're not going to try and guess why they're not random. There's actually some reasons that have to do, technical reasons with the data that I'm using. But you don't want to see a pattern. You don't want to see them where you could draw a smooth line between stuff. All right? And if you can, it's usually, if you're supposed to be seeing random data and you're seeing non-random data, there usually is a reason. Now, there's two reasons for this. Now, we're using industry-wide numbers, and there's a different number of companies in the industry at any point in time through here, because if a company goes broke, it drops out of the calculations. I could have gone through and adjusted for that, but you know what, this is the real world, so you just sort of have to build that into your expectations. There are also actually changes in economic factors that cause these to happen. We're not trying to make you perfect forecasters here. There are a lot of reasons things can go wrong with these numbers. We're trying to give you a flavor of how wrong they can go, but you got to use your common sense to go figure out if you do see patterns in a number or a series of numbers like these. It looks like these are going down, okay? So if I'm going to use the average is going to be right around here, but the later years are a lower average. So sometimes you can use measures of central tendency. Sometimes the mean isn't a very good predictor. All right, so what you're going to be doing going through here, you can go ahead and erase those. You're going to be doing this on homeowners, Group A, auto liability, Group B, and workers' compensation, Group C. Oh, God. Based on the numbers. See, I've already calculated it for you. It's nice if you know how to do the calculation, but it's an Excel spreadsheet, and it's a mechanical formula. All right, so the numbers I would pick, and I've calculated the arithmetic average, the median, the weighted average, the trim mean, and then there's a few other measures of central tendency that you could use. After this, it becomes judgment, and when you use judgment when you're forecasting, you need to be able to back up your judgment. All right, so my judgment might be that, well, what's the most recent years look like? And I might just go with that. Okay, that looks like about 1.477. That's perfectly acceptable, but you better be able to explain to somebody that, well, for that one, since the numbers aren't stable, I thought I'd pick something more recent. And I might say the same thing here, 1.145. This one looks like about 1.09. This one looks like about 1.056. This one looks like about 1.031. But if I was doing this for real, and I used to do this for real, I damn sure had a reason. Even if it was a bad reason, I wrote it down because somebody was going to ask. And most of the time the numbers aren't as well behaved as this, but that's the other good thing about using industry numbers. They are typically a lot better behaved than individual company numbers. So that's really what you have to do to prepare for your discussion board. But here's the rest of the story. Right underneath here, see where the green is? It's taking your loss development factors that you select, and it's forecasting out the rest of these numbers over time. Okay, so given the numbers I selected, if at 119,767,000,000, it's going to go out here and forecast the amount cumulative paid for each period. But notice that you only, after 10 years, you only get up to 254 billion of the 280 billion that the industry was forecasting in 2007. Right underneath that is another table, and what this table is showing you is your forecast divided by the ultimate out here. So looking at the numbers here, if I had to go do this for real, and my forecast numbers, this was 96, 96, 97, 97, 96, and then all of a sudden the last 2 years are way off. That's either something happened to the industry data that's way off, or I made a crappy forecast, okay? So what we want you to do is explain what your forecast was and explain why it is or isn't a crappy forecast in the discussion board. Group A will be doing a homeowners. If you fill in the blank here in the yellow part, that's all you have to do. It'll populate the rest of it. For the auto liability, pick your factors. It'll fill this in and then tell us how good or bad you did. That's your discussion board, is discussing how you came up with the numbers. All right, and then when we go talking about the replies, I want you to also point out, what do you see in the patterns? Here's a hint: the homeowner is going to look awful lot different than the auto liability, and both of them are going to be way different than the workers' compensation.